Trials in an experiment with a polygraph include 99 results that include 24 cases of wrong results and 75 cases of correct results. Use a 0.05 significance level to test the claim that such polygraph results are correct less than 80% of the time. Identify the null hypothesis, alternative hypothesis, test statistic, p-value, conclusion about the null hypothesis, and final conclusion that addresses the original claim. Use the p-value method. Use the normal distribution as an approximation of the binomial distribution. So we have a hypothesis test about a proportion. So in order to identify the hypotheses, we're going to need to decide what is the question that is being asked. And I always like to draw a picture. And I say, okay, we're saying something, a hypothesis about a proportion having some relation to 80% or 0.80. It says use a 0.05 significance level. Okay, that's going to be important, so we'll write that down. Alpha is 0.05. To test the claim that such polygraph results are correct less than 80% of the time. So less than 80% of the time. Now we're talking about the population proportion. Is it less than 0.8? And in order to determine this, we're going to use a sample. This sample is going to give us a sample proportion, a p-hat, that would be constructed by taking the number of successes and dividing that by the number of observations. So the question again is, are the results correct less than 80% of the time? Now we had 75 out of 99 that were correct. And if we round that to 3 decimal places, its decimal representation would be 0.758. Now remember that this is a sample. And it is impossible to draw a 100% confident conclusion about a population using a sample because of the introduction of sampling error with the process. Now, if that population proportion is equal to 0.80, then it would be very unlikely that the sample proportion would land way out in the tails, where less than 5% of the distribution resides. So in other words, if this is what the actual population distribution looks like, it's normal with a population proportion of 0.80. If that's what it looks like, then it would be very unlikely that the sample proportion would land us way out here where we have less than 5% of the distribution. So that would be alpha, 5%. Now I've chosen the left-hand side because if our sample proportion landed us up here somewhere, greater than 0.8, then we certainly would not conclude that the population proportion is less than 0.8 as stated in this problem here. So really all we're concerned with is this left tail. And by drawing this picture now, we actually are able to define these hypotheses because remember the null hypothesis is what I would reject if I land down here in this rejection region. So our null hypothesis is going to be that p is 0.8, and the alternative hypothesis would be that it is less than 0.80. Because if I land way down here, I'm certainly going to reject that the population proportion is 0.8, and the only thing left for me to conclude is that it is less than 0.80. Now it says that we're supposed to do this by stating the null and alternative hypotheses. Okay, we've done that. And then find the test statistic. So this is going to be a z-test value. And we'll do that using StatCrunch. So we'll click StatCrunch, Stat, Proportion Stats, one sample with summary. The number of successes was 75. The number of observations was 99. And we're going to do a hypothesis test for the proportion. That hypothesized proportion was 0.8, and our alternative hypothesis says less than 0.8. We'll hit compute, and we get a z-stat of minus 1.06 if we round to 2 decimal places. The next thing that we are to find is the p-value. Well, fortunately, that showed up too. The p-value we can see is 0.1456. Now, since this p-value, 0.1456, is greater than alpha, 0.05, we do not reject the null hypothesis. And we would conclude that there is not sufficient evidence to support the claim that the polygraph results are correct less than 80% of the time.